Hi students, today we will discuss about the another LAQ, current electricity. In last class, waves closed pipe has been explained. But today we are not going for Doppler effect first of all. We go for first preference, that is Kirchhoff law, and then we go for potentiometer of second preference, and then we go for Doppler effect also. Or else we go for nuclear reactor. Okay. Listen students. This chapter consists of 8 marks, okay, for TS IPE only. Now see here. Yes, listen ma. State the Kirchhoff law of electrical network. Using these laws, deduce the condition for balance in Wheatstone bridge. Now, Kirchhoff first law. At any junction in a circuit, the sum of the currents entering into it is equals to the sum of the currents leaving from the junction. Now see here, I1 is entering into the junction A, and I2 is leaving from the junction A, and I3 is also leaving, and I4 is entering into the junction. So that's why we are considering here I1 plus I4 is equals to I2 plus I3. Now we have to write the second law. Basically Kirchhoff law is based upon the electrical networks only. So first of all we have to write definition of first law, and then we have to write definition of second law. After that you have to write the Wheatstone bridge. Now see here the Kirchhoff second law. The algebraic sum of changes in potential in any closed circuits. That means sum of the changes in potential. One example, that is here the circuit diagram. It is a battery V, and this one is a I. Okay. And this one is a I current passing through the resistor. So now it can be written as V minus R is equals to, according to this definition, it can be written as V minus IR is equals to 0. V is equals to IR. Wheatstone bridge. Let us consider 4 resistors are connected with resistance R1, R2, R3 and R4 at A and C are connected to battery. Okay, see here, this A, B connected with R1, BC are connected with R3, and AD are connected with R2, CD are connected with R4. When the current is flowing I, it is divided into two currents here according to Kirchhoff first law, that is I1 and I2. And then again this I1 is dividing into two currents, that is I3 and IG. Here also same thing, when I2 enters here, both IG and I2 are forming an current I4 here. Current how much? I4. Now again I3 and I4 forms and gives to us I current. Okay. Another time the remaining current, that the current which will comes out from the circuit will be same I. Okay. Now see here, with resistance R1, R2 and R1, R2, R3 and R4. Here we are connected R1, R2, R3 and R4. And here the capital G indicates the galvanometer. Galvanometer is used to detect the current flowing. Okay, whether it is current is flowing at high or low. So for that purpose we are use the galvanometer. And if suppose the current, no current is there, then IG current will be 0. If this we have to short it, then you have to take it as, that means the bridge is balanced, that is IG is equals to 0. You have to consider IG is equals to 0 here. Then only we can obtain the balanced bridge, this balanced bridge equation. Okay. Now we will see in another page regarding the balanced bridge. Okay. Yeah. See here, when bridge is balanced, then IG is equals to 0. From Kirchhoff first law, at junction B, I1 can be written as, because I1 is divided into two currents, that is I3 and IG. So I1 is equals to I3 plus IG, equation number 1. Here the equation number 1 is given. This is equation number 1. And again here at junction, . Okay, see here at junction D, I2 plus Ig is equals to I4. From Kirchhoff's second law, at loop ABDA we get, that means closed circuit we have to take here, closed loop, right? So by this we are getting here I1 R1 plus IgG minus I2 R2 is equals to 0. That is our equation number 3. At loop CBDC, I4 R4 plus IgG minus I3 R3. These loops are considered through this diagram, that is ABDA. That means we have to consider like this, I1 and R1 plus Ig and G. This is opposite, so we are taking minus I2 R2. Similarly CBDC, that means you see here we are considering it as I3 R3. I3 R3 will be negative, minus I3 R3, and this one will be in positive because these two are in the CBDC loop direction. So IgG plus I4R, and this will be considered as negative direction, opposite direction, so minus I3 R3. Now we will see the equation. See here now, I1 R1 plus IgG minus I2 R2 is equals to 0. This is equation number 3. And similarly I4 R4 plus IgG minus I3 R3 is equals to 0, equation number 4. Now if Ig is equals to 0, then when Ig becomes 0, when the bridge is balanced. Now Ig is equals to 0, then I1 is equals to I3, equation number 5. That means in here Ig is equals to 0, so I1 is equals to I3 become. Now Ig is equals to 0, I2 is equals to I4. Now Ig is equals to 0, this whole term will be 0 here, and we get I1 R1 minus I2 R2 here, then I2 R2. Similarly IgG is also 0, Ig is 0, so this whole term will get 0 here. We will get I4 R4 is equals to I3 R3, equation number 8. We can rewrite this equation I3 R3 is equals to I4 R4 for our convenience purpose. So I1 R1 divided by I3 R3 is equals to I2 R2 divided by I4 R4. Now both I1 and I3, I2 and I4 are cancelled because equation 5 and 6 represents that I1 is equals to I3 and I2 is equals to I4. So that's why R1 by R3 is equals to R2 by R4. This equation represents the balanced equation. Okay students, thank you, and take a screenshot of this. Okay, I will make you from here, okay, clearly. So this is our question and answer, and the continuation part is this one. Okay, take a screenshot of this also. Thank you students, we will meet in next class regarding potentiometer. Don't forget to subscribe and like, okay, and share. Thank you. Bye bye students.